Hello, calculus students. All right, in this problem, we are going to locate the max and mins, relative max and mins, and use our first and second derivative tests to solve this problem. So, first thing I'm going to do is take the first derivative, and here we see we get a 6x minus 4x cubed. All right, one of the more difficult things with this problem is going to be the algebra involved. Whenever I see a higher degree term, especially with a minus sign in this in front of it, and it's in the polynomials in reverse order, I rewrite the problem and put the highest degree term first, and of course it carries the sign with it. And then, especially because I'm going to be doing a sign chart, I like to have linear factors that have 1 as the leading coefficient. So I'm going to factor out the minus 4, and I'm going to factor out an x. And when I do so, I'm left with an x squared there. The x gets factored out here in this term, but now I'm left with a minus, because the sign flips, I pulled the minus sign out, 6 over 4. And then everybody knows that that reduces to x squared minus 3 halves. Okay, now I need to factor that so I can have some linear factors so that I can use the derivative tests. So this factors as x minus root 3 over 2, x plus root 3 over 2. And that's a difference of squares. So you just take the square root of each term and then you flip the sign when you multiply the factors. So now these are factors, okay? And now that I have my linear factors, I can do the first derivative test. So I'm going to do my sign chart. Okay, so I have minus 4x, and that is 0 at x is 0. And then I have x minus root 3 over 2, and that is 0 at positive root 3 over 2. So, and then I have, x plus root 3 over 2, and that is 0 at minus root 3 over 2. Notice that these are the critical points, critical numbers, and the reason that we plot those on a sign chart is because those are where the first derivative is 0, and those are where the sign of the first derivative is going to change. Because remember, that's where we want to know where the first derivative changes from positive to negative. Okay, then I make a grid, and then I want to see what's happening with f primed, and then eventually with f. Okay, so here we go. Minus 4x is positive to the left of 0 because of the minus sign in front here, right? So you could use a test point. You could put in minus 1. Minus 1 times minus 4 is positive 4, so everything to the left of 0 is positive. Everything to the right of 0, if I put positive numbers in for x, I will get negative numbers out. Okay, this is a line, and now you can see why I like to have the coefficient to be 1, especially positive 1. Because this is a line with positive slope, so it's sloping upward. So it's going to be negative, 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 positive. And then this line is positive slope, so it'll be sloping upward. And here's the intercept. It'll be negative, positive, positive, positive. So positive, negative, negative is positive for f primed. That is negative. Negative, negative, positive is positive. And negative, positive, positive is negative. So f of x is increasing, decreasing, increasing, decreasing. So that means I have a relative max at negative root 3 over 2. Bring the 0 down here, and I have a relative min at 0. And then at positive root 3 over 2, we have a relative max. So that's the first derivative test. And I will break. Okay, so relative max at negative root 3 over 2, relative min at 0, and relative max at positive root 3 over 2. And so you can see that by the picture. We have f is increasing, decreasing, increasing, then decreasing. We could also write that in interval notation. F is increasing. So let's see here. From negative infinity to negative root 3 over 2, and from 0 to root 3 over 2. So negative infinity to negative root 3 over 2, union 0 to positive root 3 over 2. Okay, so negative infinity to negative root 3 over 2, 0 to root 3 over 2. Then it's decreasing from negative root 3 over 2 to 0. So f decreasing from negative root 3 over 2 to 0, union, and then from positive root 3 over 2 to infinity. Positive root 3 over 2 to infinity. So there's where our intervals of increase and decrease. There's our first derivative test with sign charts. And that is our first derivative with the linear factors. Alright, that's this problem. I will continue on with some more analysis of functions in some subsequent videos. Alright, good luck.